Okay guys, today we're doing 9.1b, which is adding and subtracting rational expressions. So whenever you're doing these, the first thing you always want to do is factor the denominators. In this example right here, part A, there is not anything that can be factored. Remember, this is a happy little family, so it stays stuck together, and then we have the x. After you have factored the denominator, your goal is to get the denominators to match. So the way you're going to do that is say, okay, this has a factor of 2 plus x. What factor does this one have that this one doesn't have? And it doesn't have an x, so we have to multiply the top and the bottom by it. So I'm going to write that out as a step, but most of the time you can just do it in the step before. So in math, if we give the denominator an x, we also have to give the numerator an x, because we're just multiplying by x over x, which is 1. So we're not changing the value of this fraction. So in math, you can't just go like, say, add 2 without doing something to the other side. Well, there's no other side here because this isn't an equation, so we have to be very careful to make sure that we're only multiplying by 1, because that doesn't change the value of the fraction. So that's the first one. Now over here on the second fraction, we have 2 minus x over x, and then if we want these denominators to match, this one needs an x plus 2 in the denominator, and again we're multiplying, and in order to put it in the denominator, we also have to put the same factor in the numerator so that they can this would end up being 1, and then you can multiply both sides. Okay, now you're going to be really careful, because this is a family. You're going to have to put this in parentheses, and we're going to go from there. So does everyone notice that these have, let's see, what's 7 times x? That's 7x over x times 2 plus x, plus the denominator is x times 2 plus x. I don't know why I wrote it as x plus 2. It's the same thing, but I'm going to try and come back up here real quick and just write it as 2 plus x, just for consistency's sake, so I'm not confusing you. There. Okay. Okay, so then now we're here, and we have 2 minus x times 2 plus x, so 2 minus x, 2 plus x. We got a little box method here. Some of you can recognize this as a difference of square pattern and then see your answer before we even do it. But if we're just multiplying all those together, this x squared and that, or sorry, this 2x and that negative 2x will cancel out, and I'm left with 4 minus x squared. So that goes here in the numerator. Okay, now what's happening here is I have the same denominator, so I can actually add the fractions together. So you can't combine fractions using addition or subtraction unless they have common denominators. So that's what I just did. I generated common denominators, and I'm going to take it from the 2 fractions into a single fraction using that common denominator. So that goes on the bottom, and then I'm going to do 7x plus 4 minus x squared, so 7x. Now because these are the same, I can just add the numerators, plus 4 minus x squared, and just for form's sake, I'm going to write this in standard form, so by descending powers of x. So x squared is the highest one, but it's negative, so I need to make sure that it actually has a negative right there. And then 7x has a power of 1, and it's positive 7x, so it should be a plus, and same with that 4 right there. Okay, so that is our answer for that problem. But just like before, where we have to state the excluded values, we have to go back and do that. So if at any point along the way a value of x will make the denominator 0, we have to exclude it. So we have x equals, right here, 2 plus x, so excluded value, here's the math for that real quick, so 2 plus x equals 0, subtract 2, x equals negative 2. So it cannot equal negative 2, and then the other one is just x equals 0. So you set it equal to 0, but since it's just x, we don't have any math to do, so it also can't equal 0. Okay? So that was example A. Now we're going to move on to example B. In example B, we're going to add a step. So the first thing I said was whenever you're doing these, your first step should be to factor. So that's what I like you guys to do on this right here. So, oh my gosh, this is so cool. Look, they already have common denominators, so we don't need to do anything with that, but I am going to factor this real quick. So another way to write x squared minus 49 is to write x plus 7, x minus 7. So the reason why we can do this is because this is a difference of perfect squares, and we've already learned this pattern. So if you have a perfect square minus a perfect square, it factors into a plus b, a minus b. So that's so cool. So since we already have the common denominator, we can now go from two fractions to one fraction. So once you have the common denominator, it's the denominator of that single fraction. And now we're going to add. So we have negative 10x, and 9x makes negative x, because they have more negatives than positives. And then negative 10 and positive 17 makes 7. So now we get to this point right here, and you're kind of thinking like, am I able to cancel this with one of the denominators, because this could be a family. Well, this negative x, this one's a positive x, and same thing over here. However, they like to be a little bit tricky. Anytime you see something that's really similar, you're going to want to factor out a negative 1. So you're going to hockey stick this. So negative x divided by negative 1 is positive x, and positive 7 divided by that negative 1 is negative 7. You see that right there? So what that means is, now that I've factored out that negative 1, I can cancel these families and send them on vacation. And so then my answer is negative 1 over x plus 7. So then we got to do the excluded values. And remember, when you do your excluded values, you're going to want to start from the beginning of your problem and not just look at the answer in the box. So right here, wherever you factored, is the best place to look. So we can see x cannot equal negative 7 or 7. So again, just set these equal to 0. Or at this point, you might be able to do the math in your head. Okay? So now we're going to move on to the next one, which is where we're subtracting instead of adding. So step 1 is to always factor. Just give me 1 second. There we go, a little more focused. Step 1 is to always factor, and I know you guys are looking at x squared plus 1 and thinking maybe I can factor that. But remember, it's a difference of squares. So you can only factor if this is a perfect square and this is a perfect square, which they are, but there has to be a minus sign in between them. So we cannot factor these right here. If they were cubed, we could factor them with like the little and big parentheses, but with squares, it's only difference of squares, which is kind of nice because then it eliminates a choice for us. So because we have the same denominator and it can't be factored, we're going to take this from two fractions to a single fraction by subtracting the numerator. And a lot of you can do this step in your head, but I just want to put it on there so you can see what it looks like. This denominator only has one term, but if it had two, we would have to subtract both terms. So that means we would have to distribute the minus. And we'll probably see that in a second. So let's just see. So we have x squared plus 1. And then here we have 5x to the 4th, and 3 minus 8 is 5. Oh, do you guys see what I see? We have something in common in the numerator. So we're going to hockey stick that out. So 5x to the 4th divided by 5 is x to the 4th, and negative 5 divided by 5 is negative 1. So here we are at this point, and you might be thinking, all right, we're good. But this is actually a perfect square. So in math, the definition of perfect square is the number times itself. So something like 5 times 5 is a perfect square, or x times x is a perfect square, because the number times itself. X to the fourth is also a perfect square, because if I take a number, x squared, and multiply it by itself, I get x to the fourth. So I have a perfect square and a perfect square. So I get to do the difference of squares pattern with that. So it's going to be take the square root of x to the fourth, which would be x squared, and then 1, and put the sign change in between. So why would I want to do that? Because look at now, I can send this happy little family onto vacation. So my final answer is 5 times the quantity, x squared minus 1. Right there. So yes, we could factor this if we wanted to, but it doesn't change the problem in terms of being able to reduce with another denominator, because there isn't a denominator. So at this point, this is our final answer, but we have to ask, is there no excluded value, 2 excluded values, or 1 excluded value? So to find the excluded domain, we got to go look at the denominator. We're not going to look at this one, so excluded values. So we set x squared plus 1 equal to 0, and then subtract 1. So we get x squared equals negative 1, and then we square root. So we get x equals plus or minus square root negative 1. Well, you can't have a negative under a square root, okay? So there is no excluded values for this problem. Why? Because this denominator will never, ever, ever equal 0, no matter what number you plug in for x. So let's say, yeah, right, Wilkin, what about when I plug in negative 1? Well, what's negative 1 squared? So that's negative 1 times negative 1. That's 1 plus 1. So it can't be negative, right? So this square is going to make everything positive, which is why we're going to have no excluded values, okay? So that was a little bit tricky, but we can handle that. We're moving on to our next one. We're adding this time. These denominators are not common denominators, but they look really similar. So we're starting to pick up, if we see that these terms are similar, but like opposite signs, then we should factor out a negative 1 from the one that's negative. So I'm just going to copy this first one. And if you're noticing that that's a difference of squares, that's awesome, because it is, and we will get to that in a second. But we're going to factor out a negative 1 from this right here. And the reason why we want to do that is because then we actually have common denominators. Do you guys see that? That's awesome. So we don't want to leave the negative in the denominator. And since there's only one term in the numerator, we can move it up to the numerator. It's equivalent mathematically. Alrighty. So now what we're going to do is we are going to combine like terms. So we're going to write this as a single fraction. So we have x squared minus 9. Maybe we'll need to factor it. Maybe we won't. We'll see how it goes. But we have x to the fourth minus 80 minus 1 from this guy right here. Or plus negative 1. It's the same thing. So then I have x to the fourth minus 81 all over x squared minus 9. Do you guys notice this as a difference of squares in the numerator right here? So x squared times x squared is x to the fourth, and 9 times 9 is 81. So I'm going to use the difference of squares pattern there. And I haven't factored the denominator yet because I know where this problem is going, but if you did, it would still work out for you. You just would factor the numerator as well. So x squared gives us x to the fourth. This is negative 9x squared to be canceled out by the positive 9x squared. So these are canceled. and our answer is x squared plus 9. So now the question is, what are the excluded values? So that's where we have to go look up at our denominators. So the denominator was the same, we just factored out a -1 from it. So we are just going to do x squared minus 9 equals 0 to find our excluded values. So that would be x plus 3, x minus 3 equals 0. So the excluded values are going to be -3 and 3. Alrighty, let's go ahead and flip that over so we can see what other stuff we got going on in this note sheet. Whoa, it looks like we stepped it up big right here, right? Combining fractions, but now we went from some denominators with only 2 terms to denominators with 3 terms. So these are not similar, so I don't need to factor out a negative. What I do need to do is recognize that there's 3 terms. So I'm going to t-chart both of those real quick. So here's the first fraction. Okay, so this one's going to be x minus 5 and x plus 4 minus, whenever I see a minus, I kind of like set up a red flag in my head because I know that I'm going to have to be really careful with my math there. Minus 8x, 15, x and x. A lot of times these problems are rigged. So I know that 5 times 3 makes 15 and 1 and 15 make 15, but because there's an x minus 5 over here, I'm going to try that one, because usually they're a little bit kind to us and try and give us at least one piece of the denominator in common. So they don't have to, that's, you know, but these problems are kind of rigged, like I said. There. Okay, so that's where we're at with that first part of the problem. So we factored, and now we're going to do what we said before. What does this denominator need that this denominator has? So they both have an x minus 5, so this doesn't need an x minus 5, but this one has an x minus 3 and this one doesn't. So this fraction right here, in order to get common denominators, needs an x minus 3. So that's what we're going to give it real quick. Just getting a different color pen. So this needs an x minus 3 and an x minus 3. And then on this side, what this one needs is, it has the x minus 5, it has the x minus 3, but it needs the x plus 4. And mathematically, to keep these equivalent, I need the x plus 4 in the numerator. So this is where I need to be really careful, because now I have a family up there, and the minus goes to both members of the family. Alright, so let's see what we get. So 1 times x minus 3 is x minus 3. And just real quick, I'm taking it to a single fraction now because I have common denominators. And the order of the factors in the denominator does not matter. This is because of that commutative property in math, so just think about it with numbers. 2 times 3 is the same thing as 3 times 2. So the order in which I said to multiply those two numbers doesn't matter. So it's the same thing with polynomials. Alright, so I have 1 times x minus 3 minus 1 times x plus 4. So you can put this in parentheses as well, just if you're like, why did she put that one in parentheses and not that one? Because 1 times anything is itself. And now we're actually going to do the math of the minus. So I have x minus 3 minus x minus 4. If you're doing a subtraction problem on my HRW and you're getting it wrong, like 9 times out of 10, the mistake is going to be because you forget to put that minus to the other member of the family and you put a plus 4. So always check that before you ask for help. So x, circle, x, oh, opposites, sweet, those cancel out. and negative 3 minus 4 is negative 7. So I get negative 7 all over x plus 5 times x plus 4 times x minus 3. And I can't cancel anything with the numerator and denominator, so that is the final answer. And the last thing we have to do is just get our excluded values, which are from the denominator, and we have 3 pieces, so we're going to have 3 excluded values. We have x cannot equal negative 5, negative 4, and 3. Right, guys? Okay, 2 more problems and then we'll be done. Let's take a look at this next one. It's subtraction, so I'm already kind of going to proceed with caution here. Okay, so first thing I'm going to do is factor this right here because there's 2 terms. So it should be x plus 4, x minus 4 because it's a difference of squares, minus x plus 4 all over x plus 5. I can't factor this anymore. It's just a happy little family sitting there. And so is this guy actually, for that matter. So I like to put parentheses around them just to make sure that I don't miss anything. So the next thing is to get common denominators. They both have an x plus 4. This one needs an x minus 4. Ooh. Went straight for the minus on that one. Okay, so when you go to do this part and when you go to combine them, it's going to be best if you take it step by step. So this is x plus 4 times x minus 4. Because I have common denominators, I'm ready to take it to a single fraction. This 7 didn't get multiplied by anything, so it's going to go there. But I'm going to write this just like this, okay? And then you're going to need to do the math for this in a second set of parentheses. So when we multiply that all out, we need to make sure we keep it in parentheses till we're ready to do the subtraction piece, because if you don't, you'll get the wrong signs. So whenever you're multiplying something that has, like this, more than one term in a subtraction, put your answer to the multiplication in parentheses. So real quick, box method, just so I don't make any mistakes. X plus 5, x minus 4, x squared, negative 4x, 5x, negative 20. Combine like terms, more positives than negatives, so it's going to be x squared plus 1x. I'm just going to write x minus 20. Alrighty, so then now we're going to distribute that minus sign, so everything changes signs. So 7 minus x squared minus x, and a negative times a negative is a positive, all over x plus 4 times x minus 4. And then I'm going to combine like terms and put it in order by descending powers of x. So descending powers of x is like x cubed, x squared, x to the first, okay? So x plus 4. The common denominator stays with these problems when you're adding and subtracting fractions. So I have negative x squared, and then a minus x, and then I have the 20 and the 7. So plus 27. And that right there is our answer. So some of you might be thinking, couldn't we t-chart the numerator because it has 3 terms? Yes, and I'm glad you have started to see that. So plus x minus 27. That's what happens when we factor out the negative, just for the numerator real quick. And then I'm looking for 2 numbers that multiply to give me 27 and that add to give me 1. Now, any of the numbers that multiply to give me 27, are they going to involve 4 or negative 4? And the reason I'm asking that is because that's the only way these factors are going to cancel. Well, if you know anything about odd numbers, you cannot multiply, like 4 times 27 is not, there's nothing that makes 4 times something that will give you 27. So there's nothing that's going to cancel. So instead of doing the whole t-chart, you're just using a little bit of forethought to see if it's going to work out, and it's not. So, and then our excluded values are -4 and 4 from the denominator. All right, last problem, almost done. Sweet. Okay, so for this one right here, we got a lot of factoring we got to do before we can get started. So 1 over, ooh, those have an x in common, so I am GCFing that. And then here I have a difference of squares. So in the first step, all I'm doing is factoring. Alright, so there we go. Now we got to get common denominators. So this one needs a 2x minus 3. And the second fraction has the 2x plus 3 and the 2x minus 3, but it needs the x that's right there. Okay, so now that we have the common denominators, we're going to combine it to a single fraction, because that's the whole point of combining fractions. And I get to that, and then I'm going to do my math. I have 1 times 2x minus 3 plus -2 times x, which is just -2x. Oh, look at that. 2x and -2x, those cancel out. So I just have a -3 all over x times 2x plus 3 times 2x minus 3. And nothing is going to cancel there, so that would mean that is the answer. And then the last thing I have to do is get the excluded values. So we're all very comfortable with that right there. So we have x cannot equal, and there's going to be 0. It's going to go in the middle. But what about the other ones? So if you're going to do your excluded values and you're not sure, if you can't do it in your head, we always have this fallback plan of setting each one of those factors equal to 0 and then just doing the math. So 2x equals -3. Oh, we're going to get a fraction. So -3 halves, and I bet you can guess what this is going to be, but we'll do the math for it just for fun. And 3 halves. Okay, so those are excluded values there. That's it. Have a good day.